Today we're going to troubleshoot my Cerwin Vega XLS-15s active subs. I've had these for about 5 years, purchased in 2014. Over time they've developed differing issues. The one on the left, it doesn't seem to turn on when it receives a LFE signal from the receiver, and the one on the right turns on randomly even though it's not receiving an LFE signal from the receiver. So in these two instances, I think the circuitry issues may be the same, but we're going to deep dive into it and find out exactly what's going on. As of recording this video, there was no schematic available as far as a service manual on the internet at all. So we are going to be flying blind while repairing this, and we'll see where we end up. Join me for the journey. Okay, here are the rear of the units. The one on the left, as described earlier, does have an issue as far as not turning on, even when it's receiving the LFE signal, which brings the unit out of standby. And the one on the right seems to turn on randomly, even though not receiving an LFE signal from the receiver. Tends to happen about midnight, and you wake up going, what the hell is going on, when this thing's pulsing and it's thumping away in the background, and you have to go turn the power off to it. So both units will be looked at and investigated to see what's going on. As I said, they're about 5 years old, so we'll see what we can find. So we're going to start with the one on the right first. This unit is the one that turns on out of the blue without any signal. And yes, before anyone asks, the receiver has been tested and it's not giving out any false signal. So the receiver has been ruled out of having the fault with it. It does seem unusual that both units have been affected in different ways, but seemingly at the same time. I suspect perhaps maybe a power surge, something along those lines, but I'm not sure. They're not completely dead. They still do technically work, but there is something funky going on with these guys. Okay, before we proceed any further, might run some tests to see if we can supply this a signal from a SIGGEN and find out at what level it comes out of standby, if at all, if it comes out of standby. So what we need to determine is we'll feed a AC signal into the LFE in port, starting at 0 volts, and we'll work up to whatever point the unit comes out of standby. So we'll see the red light change to green, and we'll make a note of that, that reading. And we'll do that to the other unit as well and see if they're comparable in those results. Okay, I got my signal generator set up here, and that's what's going to supply a pseudo LFE signal into the unit to try and get this to trigger as if it's receiving a signal from the receiver. I want to record at what point and what voltage that trigger actually activates the subwoofer. I want to keep that as a baseline and compare that with the other subwoofer to see if they're on par or they're completely out, and see whether or not there's an issue in that regard. That might give me a bit more of a clue to how to trigger or how to diagnose the issue, what part of the circuit to look at, and just give me an overall better idea of what's going on. So what I've done here, I've put an RCA jack and clipped it onto my IC clips. So negative goes to the surround and positive to the middle. Doesn't really matter because we're going to be supplying an AC voltage anyway, as you would from an LFE signal. And we'll see if we can get a voltage that will dial in from the SIGGEN. Probably about 100 hertz, just something within the range of this unit. So anywhere between 50 and 100 hertz. And let's see where we go from there. So I'll get some power set up for this unit. I'll get some power set up for the SIGGEN, and we'll go from there. See you back shortly. Okay, I now have the signal generator hooked up through the LFE port on the sub. I've turned the volume of that sub right down to minimum, just in case I get that 100 hertz sound through here. I don't want it shaking the workshop apart. So I have mains connected to the sub. It's currently turned off. So what I'll do now, if you can just see, I don't know if you can see that in the shot. I'm set at 100 hertz. It's going to be a sine wave. The amplitude at the moment is 0. And I've got the cursor set on the tenths mark of a volt. Tenth of a volt mark. And I will adjust that at 0.1 increments. And then note at what voltage the subwoofer turns on at. At the moment, you can see here, this is actually turned off, but I don't know if it's coming out on camera. Every now and again, there's a little flicker of the standby light. If you can spot that. Maybe, maybe not. But every, I don't know, 5 seconds or so, it flashes red very dimly. Don't know if that's normal, but we've got to find out. Alright, I'm going to turn on the sub now and see what we get. Okay, the standby light has actually lit up red, and you can actually see it on camera. Beautiful. The output of the SIGGEN is on, as you can see over here. Green LED for the channel is on. Now I'll slowly increment the input voltage and see. Oh, it's actually turned on. Well, that's no good. That is really odd. All right, we'll see what we can get out of it. All right. Here we go. It's faulting. Well, that's fantastic. That's happened. And it should come back on the red for standby. So this unit is actually faulting right now. Now it's back on. There was something going on. Either I've got a ground loop issue or there's an issue with the unit. Okay, we'll see what we can give it some signal. 0.1. Ooh, 0.3. 0.4, 0.5. Let's give it some volume. What is actually working? Down for now. Well, that's unfortunate because now we don't know where the unit will trigger to come out of standby. Let's shut this down. I'll leave this at that volume. It's not too bad. So what we'll do, we'll turn it back down to 0. We'll turn the unit back off at the power, at the mains. Let everything shut down, let the caps drain, let it slowly fade out, and we'll turn the main switch back onto the sub and go from there. Okay, turning the sub back on. We're in standby mode. Now we'll increase the voltage. 0.1, 0.2. Right, at 0.2, the red light has gone off. 0.3, 0.4, still no relay clicks at the moment. 0.5, 0.6, 0.7, 0.8, 0.9. It should have turned on by now. That's nearly a volt. That is a volt going in. So I'm not going to put any more in now. We'll turn that right back down to 0. We'll turn the unit off. We've actually lost the standby light altogether. I think we're in for some really tricky diagnosis here. We've got multiple issues going on by the look of it. Let's turn the power off. Give it a few minutes. Be back in a second. Okay, it's been a few minutes. We'll see if we can replicate that last issue. So SIGGEN is set to 0 volts. The unit is actually off at the moment. Still got our LFE connected. The volume of the unit is stayed the same. So we'll turn the unit on now and see what we get. Okay, standby light flashed red, then turned off. It doesn't appear to be anything going on. No, No standby light whatsoever. So we'll introduce some voltage. 0.2 volts, 0.3, 0.4, 0.5, 0.6. I'm not going to go any further than that. There's no need. If there was an issue with the input side of the circuit, it's probably completely foobarred now. No, we've got no action out of this unit whatsoever. Okay, so we're going to return the unit back to 0 volts. Okay, we'll switch over to the other sub and we'll do the same test and see what we can find out of that. Back shortly. Okay, we're at the sub marked left, which is my other unit in the system that I run. The setup is exactly the same. We have SIGGEN into the LFE port, volume set to about, well, say 9 o'clock on the dial there for the input volume, or sorry, the output volume. Low pass frequency sitting at 150 Hertz. Okay, same test setup. SIGGEN in, 100 Hertz feed, sine wave, 0 volts amplitude at the moment. The unit's turned off. I'll turn it on, let the sub settle, hopefully just enters straight to standby mode. Then we'll increase the input signal 0.1 volt at a time until we see the standby change to on. And this will determine whether or not the system is reacting properly to a supposed LFE input if it was connected to a receiver. Okay, so here we go. Turning the sub on. Instant red standby light, exactly what we want. Then we'll slowly increase the input voltage and see what happens straight away. And then we'll have another secondary click. We can hear our signal. So this unit is actually working as it should. Getting louder each stage. That was up to 0.7, now I'm backing it off. That seems to be working exactly how it's supposed to, as intended. Well, that doesn't explain the random turn on in the middle of the night. This unit here is the one that turns on without any input. The head receiver is turned off, and this will basically turn on in the middle of the night and pulse. A sort of a low frequency doof, doof, doof every second or so until you turn it off at the wall to take the mains away. Okay. Turn back off. Now, this unit, as per the manual, says once it's finished receiving or not receiving an LFE signal anymore, so simulating turning off the head unit or head receiver in your theatre setup, that the standby light and the unit will shut down within 30 minutes. So we're not going to wait 30 minutes now. We'll simulate turning it all off. Let all the caps discharge and all the parasitic voltages soak away. Standby light seems to be fully extinguished. Okay, we'll turn it back on. Straight into the standby mode. I think you can see that. Yep. Then we'll give it some voltage on the input. Now, it turned on at 0.1 before. Let's see where we go now. Exactly the same thing. 0.1 turns on. And we're straight into our signal that we've got. Obviously, we can adjust that via volume. Okay, the low pass filter has no effect on the LFE input. And I do believe reading that in the manual, So there's no effect. I believe the low pass frequency filter is only for the high level inputs, which we don't use. I don't use, because I just use the LFE feed straight from my receiver into the units. And all it is I'm running 2 subs. The same signal gets split off on a fly lead, 1 to each sub either side of the room, and that's exactly how they operate and have operated for the last 5 years, no problem. Why have 1 sub when you can have 2? Symmetry, it's all about the symmetry. Okay, well this seems to be working fine. That's on 0.1 of a volt. Let's turn this back down. This is working as intended. This is really odd. Okay, well we're going to leave this unit for now. We'll continue opening up our right hand sub and see what we can see on the circuit there. So I'll finish undoing all those screws and we'll see you back on the bench. I'll hold the unit in so it doesn't fall out all over the floor. Okay. Can we get this off? Making sure I've got all the screws out. Up here, so. Oh, here we go. Yeah, it's going to be a fairly weighty unit because you'll have the transformer and all that integrated. And sure enough, we do. Okay, the sub line. Let's see if we can get a better shot. Ooh. Here's the sub line. There's the speaker there. It's a fairly hefty unit. Okay, let's unclip that. That's the speaker off. I do believe that's the only connection. We can walk away with the unit. Looking at that, amplifier board, transformer, looks like the power handling board. This is one I have repaired before. I do remember having to repair a op amp. Now I recall it was a similar issue, but I'm not too sure. And this is your interface board up here. This will have all your outputs, inputs, volumes, and your LFE signal. I'm not sure how much processing that does, but we can certainly have a look. All right, I'll meet you back on the bench and we'll have a closer look. For all you guys playing at home, this is the inside of the cabinet. And that big cast basket on that sub, 15-inch sub. Let's check out if those stay-cons are firm. Oh yeah, they're not going anywhere. Mind my finger, I cut myself earlier. Yeah, no, that's fine. Fully lined. That's a beefy sub. Let's get a measurement on that because that's huge. Okay, what have we got here? Oh, that's a crappy rule. Be back in a sec. Okay, I don't have a rule with inches on it. This is a first world ruler, so we've got centimeters. Let's have a look here. 16, 15. So we're looking at about just over 5 inches across. 5¼ inches maybe. Or 16 centimeters, 160 mil. That is a decent sized magnet. As you can imagine, this subwoofer is immensely powerful when it's in action. Definitely gets the old house shaking, and I believe it's even cracked some of my walls. And then you times that by 2, because I do have 2 units running at the same time. Definitely makes for an immersive experience on an action movie, much to the disappointment of the neighbours and probably most of the surrounding suburb, but that's their bad luck. Alrighty, let's get looking at the circuit. Okay, we're not back at the lab bench at the moment, but what we are looking at is the Toroidal Transformer. I'm not sure of the voltages, but saying that, they normally do come with a sticker or a label. And of course, it's on the part you can't see, so it's been rotated. It's actually on this side here. If I need to remove that to find out where or what the voltages are coming in, I'll do that at a later date, make sure I get a shot of that. But here we have two boards sandwiched together. Looks like we have the high voltage input from the mains through the IEC connector with fuse, the voltage selector, and the mains on-off switch. A couple of X-class capacitors, some smaller filtering caps, that may be for the standby voltages. A tiny transformer, probably supplies logic 5 volts, I guess, for the standby circuit. And Chang X, oh yeah, you wouldn't think a US made, is it US made? Okay, designed and engineered in the US, made in China. So they've cut some corners, they've used some really cheap and nasty capacitors here, and this doesn't seem to be domed, but probably is a candidate for be swapped out anyway. I've never had any luck with Chang X capacitors at all, so that's a bit disappointing. Some signal wires coming in. This is the AC from the transformer coming in and going out, obviously. So we've got mains going into the transformer. Is that handled from that same board, or is that coming separately? Oh, okay, what have we got here? Oh, okay. We have. This is interesting. It looks to be that your center tapped voltages coming out from the transformer is going straight to the amplification board through its own set of, well, that is interesting. Comes in through its own set of bridge rectifier diodes. They use discrete diodes here rather than the whole bridge rectifier or bridge rectifier unit, so a solid state unit. Oh, today is tomorrow. Let's get stuck into this subwoofer again, find out what's going on. I've had a bit of time to think about this overnight. I've come up with an idea on how this all works as far as all these little subboards and whatnot. Give me a sec, because what I'll do is quickly have a look at the instructions. It's got some heft to it. Doesn't really give us any useful information apart from where you plug things in, the actual installation detail, high level, low level inputs, LFE. There's no circuit diagrams, no service manual, nothing. A little bit of troubleshooting, but apart from that, we've got nothing really to work with. So let's disseminate what's going on with this unit. So my theory is we have a unit that remains powered full time, generally, sits idle, waiting for a LFE signal to come through the input jacks. That signal in turn triggers the relay board to turn on. For all that to happen, there must be an underlying voltage in this circuit from the mains permanently live within this unit. What I can tell, this bottom board here is connected directly to the IEC connector, which is where the mains goes, the voltage selector, and the on-off mains power switch. We can see that the transformer does actually connect to this baseboard, and we know that there's a relay there which switches that transformer in and out. So if that transformer is not on by default in standby mode, what is? What is supplying the logic voltage to this unit? Now I would suggest this bottom board here is responsible for supplying that logic voltage to keep the standby circuit live while this sits lying in wait ready for this LFE signal to fire it and kick it into action. I suspect that the voltage for the current and power supply for the standby circuit is derived from this bottom board. So what I can see, we've got a connector here, and then up the back, probably can't see it on camera, there's another 3-pin connector header there where these two boards sandwiched together. Now I suspect that this top board is responsible for waiting for that LFE signal, picks up on it, turns the relay on, turns the whole unit on by connecting by energizing the transformer, which in turn energizes the amplifier board, and then it's all ready to go. I suspect before that is happening, this power supply circuit is probably not up to snuff and it's faulty. So we've got to go through systematically and check for the voltages we need or require. But without a service manual, we've got no idea what we're dealing with. We can tell though, up on this top input board, I don't know how well you can see that, we've got S out, GND, which is ground, S on, I don't know, it might be sub on or standby on or something like that, 15 plus volts, P ground, minus 15 volts, LED. So this seems to bridge from the input board through to this secondary plug, and then this plug through to this board here. Now, I'm convinced that this top board is just amp, and it's just for the amplification for the sub. And this board here is responsible for detecting that LFE signal and then turning the whole unit on. And this board down here is just power supply, as well as the interconnects for the mains and the relay for the transformer. So I think the first order of business might be to separate these two boards and see what we have laying underneath, and see if we can reverse engineer the circuit, see if we can see anything that might give us clues to what's going on. Okay, I put the power board on some blocks so it stops rocking around on me, and we'll start looking at removing this board here and go from there and see what we can see. Okay, we'll remove our connectors, see what we've got here. Yep, easy. Let's remove our transformer connectors, just get them out of the way for now. That's interesting, a bit of a earth lead that goes through. Oh yeah, it goes through the IAC jack. Righto, fair enough. It should pop off, like so. And we've got 1, 2, 3 screws. They go into standoffs. Let's see, we'll get rid of those. Single-sided board. JRC, what was that, 4558D? I believe that's an op amp, maybe a dual op amp. I think JRC stands for Japan Radio Corp. Not a bad little op amp, those. Okay, can't see any obvious markings for these connectors, although this one only seems to have 2 of the connectors connected, 2 of the pins connected. I'll buzz it out with a multimeter at some point, but no obvious physical defects I can see on that board. Okay, let's have a closer look at this bottom board here. So as you can see, there's a fair few obvious circuit component choices for what I've suggested earlier, that this is a power supply supplying our let's say 5 volts for our logic circuit, and to run our relay there to click in and click out those windings on the transformer. Ooh, there's a bit of corrosion going on down here. Let's have a closer look at that. Don't know whether that picks up on the camera, but that is not looking too flash. Not good at all. Okay, let's get some numbers off these ICs and see if we can find out what these ICs are, and it might tell us a bit more about the circuit overall. Okay, on further investigation, it appears that this is a switch mode power supply. The OB2353 IC there is just a switch mode driver. And looking closely at it, I don't know whether you may be able to see in this bottom corner here, there's a service mount capacitor, optocoupler, and what seems to be a MOV sitting over the top of it. The bottom section is corroded. I don't know what's going on. Don't know what's going on at all. I might put it under my microscope and have a closer look. I'll have to take the board off or out of the unit, which is a bit of a pain in the backside because we've got the IEC connectors soldered directly into the board, and the power switch is soldered directly into the board. And it would appear a while back I've been in here before and disconnected the voltage selection switch because we only operate 230 on 230 in here in Australia, so I didn't want any risk of the voltage being selected. So I've hardwired the switch into 230 volt position and disconnected the selector switch altogether. So what I might do, I'll desolder the switch and the IEC connector, take the board off, and we'll get under the microscope and have a closer look. Okay, the patient's now on the electronics bench, and we'll fire up some equipment and desolder that main board off the IEC connector and the power switch. Let's get some gear fired up here. I'll be back with you shortly. Okay, we can preheat the area a little bit, get ready for desoldering. Not too much, just a bit. Okay. That's that bit. Now I need to get the switch. Just going to move you a little bit. Okay, that should be enough to set it loose. Oh, beautiful. Okay. It looks a bit scruffy around those points there. I might have to do a bridge wire. I believe that goes across to the switch. Oh yeah, far top corner, switch near the bridge there. It's looking a bit, how you doing? This board's not the best quality. We'll make it work though. Okay, that's least of our issue. We've got some corrosion down this connection point here, which I believe is the... It looks to be the feedback circuit for the switch mode. Anyway, let's throw it under the microscope and have a close look at it. Okay, I've got you set up looking at my monitor for the microscope, and if we zoom in, this is appalling. What is going on here? That's just crazy. What the hell has happened? There's corrosion on that actually, where's the pointer? You can see corrosion on this capacitor. It seems to be leaking out of the capacitor, which is, that's unusual, highly unusual. I don't know what's going on here, so what I might do is neutralise that with a bit of vinegar before we even get started. That's pretty bad. Okay, we've got some white vinegar. Put a couple of drops on there and see what happens. Now, it's obviously not battery acid because there's no battery on here, but let's see if we get some sort of reaction. It's pretty bad, whatever it is. I'm not sure what's caused that. Any idea? Does the blue mauve that I see over the it's just graphite coming off the tip of my pencil here. Can the mauve leak? Because it seems to come down the mauve leg that's sitting over the, I guess to protect the optocoupler. But this is not looking great. I might get a toothbrush rather than this pencil. I'll try this X-Acto knife. I'll have a look. Don't want to remove any track. So I might give this a clean and start again. Oh, look at this. This capacitor is just falling apart. This is part of the feedback control. That's no good, not a good sign at all. But I think we're on the right track for this failure on this subwoofer. Okay, let's see. It's shocking. Yeah, that capacitor's had it. It's shattered. What's going on over here? More corrosion. This is terrible. I've never seen anything like it, especially from a MOV. Let's look down sideways and see what we can see. I'll try and zoom that in. Whole leg of this MOV seems to be corroded. Wow, this is bad. Yeah, it just turned into a paste. This is terrible. I'm not sure what's going on here. Green, that means copper oxides. This track seems to be still intact, although exposed. There's a bit of gap in it. I'm happy with that. Yeah. Not happy, Jan. Not happy at all. What's caused that? I might clean this up off camera. This is going to be a tedious process, and we'll see what we're left with back shortly. Okay, let's see if we can get rid of some of this corrosion. A bit of a scrape around. It does seem like corrosion. It's pretty bad. Wow. Oh my god. What it's doing to the solder? It's just falling apart. What the hell's going on? It's almost like what gallium does to aluminium, or aluminum. What has done this? The neighbours over the road seem alright, but this is just shocking. Is there any fresh stuff? Oh, that's just disgusting. It's just pushing it around so easily. I'm not even putting much force on it. Terrible. And that's the back pin of the MOV. Okay. Two pins together. Here's the pin of the IC. That's the back. Oops. These two pins are one side of the optocoupler, that's on the other side. But this is just falling apart. This has not had water damage. So it's not water corrosion. I don't know what's caused this. I've never seen anything like it. It's actually taking the tin off the legs by the look of it. Yeah, oh my god. Yeah, the other side's alright. Although the soldering's not that great. Let's see what that MOV says. X1Y1 400 and 250 volt. So why would it be high rated across there? Just surge protection. That's all it is. But it's just to protect the what seems to be the optocoupler. I think what I might do is take it out of circuit and see what damage we've got. Once I take it out, have a look at the pads and traces and go from there. Okay, so after removing the MOV, we can see more corrosion. So what we might do is see if we can re-wet all this area. Let's put some flux on. Might even take that opto out, I think. Clean this right up. Let's check this guy out. He seems alright. The legs aren't weak or breaking off. This is Everlight unit, I think. Let's have a look here. Oh yeah. The old garden variety EL817. I've got a crap load of these anyway if there's any issue with it. But for the time being, we're going to reuse it because I don't think there's an issue with this. A bit of the crap off. Let's have a look at the other side. The other side looks clean as. Got no issue with that. Alright, we'll put that aside for now. Back to our board. Get more flux. Way too much flux. Never mind. Put some fresh solder on there. I'm going to drop the heat of my soldering iron down to 300. I don't want to cook off the traces. See how we go. Some corrosion right there. Yuck. Not plain solder. Let's clean that tip. that trace. The trace is too thin. I'm gonna have to put a bridge wire in. And this little guy, it's just about foobarred. Let's get him off. Okay, it's looking better, it's not perfect. It does seem to be still a bit lacking, but I guess it's better than what it was. Only we've got to find what that value of that cap was, because it's completely foobarred. Let's have a quick look at that. Yeah, one whole end cap's fallen off. Bit of corrosion. Let's look and measure it, see what it is. See if it's still got some sort of value to it. 12 NF, 11, 10. All of the shop. Okay, back at the bench. We've made some changes. There's some significant changes made to the circuit. Let's see if we can get some focus here. Working with what I've got, the corrosion seemed to be repaired. The 100 nanofarad capacitor has been replaced. SMD component is in there. Track's repaired. The X-class capacitors that were on top are now being relocated to underneath, and they still clear the switches and hardware underneath. The reason why I did that is because trying to desolder this switch for future servicing is just an absolute nightmare with that capacitor in the way. So instead of just moving the one down, I've changed all three and just relocated them underneath the board. The whole board sits off the chassis anyway with standoffs, so there's no real issue with clearance there. These Cheng X capacitors, I'm in two minds to change them out, but the problem is they are 400 volt. I don't have any 400 volt capacitors in stock at the moment, but what I will do is desolder them, seat them right down, and then resolder them in. And I think we're pretty close to testing. Just going to resolder these capacitors, the electrolytics, down on the board, and then throw it back in, get some mains into it, and see if we've got a steady output on this header here. I still don't know what the voltage is, but it's got to be something, and we'll go from there. This connection here, the pad's missing, top side, but underneath that board, it's all intact, but I'm not going to be able to solder that from the top side of the board. So what I'll do is just get a jump wire which goes to the top corner of that switch there and just solder it directly once it pops through that board, and that should sort that out, and we'll go from there. So reset those caps and we will see how we go. Okay, testing time. I've put the board back into the chassis, and the three brass standoffs that help locate the board mechanically are back in. And the little bridge wire, like I said before, where I've lost, you can't really see it from that angle, I'll move you over here. I've lost the through plating and the part of the pad that sits around this connection here. So I've just done putting a mod wire basically between that and the actual position on the switch where it goes to via a track underneath the board. Like I said, relocated those X or Y class capacitors. I wasn't sure. I don't know, X class I think. They're located underneath now, out of the way, so if I ever need to desolder this switch to get this board out again, I can do so without melting the capacitor away. Relay's okay. I can a bit more visual space on the PCB now, and I can see a lot more of what's going on the board, especially for a servicing point of view. All the corrosion's been repaired the best I can. Haven't really lost any tracks, but I've just reinforced a piece of track there that looked to be a bit thin, but that seems to be okay now. The MOV has been cleaned up. Any corrosion on the legs have been scraped off and fixed up there. So now it's time for the test. Put mains power in and see whether we get I'm not even sure what voltage, 5 to 12 volts I'm guessing, out on that output there, and that should remain with no noise. I might then connect this power board to my isolation transformer and put the oscilloscope on the output there and see if I can see any noise and see if it's a clean steady voltage that's coming out, and we'll go from there. All right, back in a sec and we'll have it all hooked up, ready to go. Okay, mains cable connected. Now I'll just turn the main switch on the bottom. Hopefully we don't blow things up. Seems to be good. Okay, I'll plug the secondary board in and see if we can get a just unplug that mains cable and plug this earth cable back in. There we go. See if we can get a voltage, some sort of output. Minus 1.8. Interesting. 1.8 seems a bit low. Alright, let's turn it off and see if we can get standby on. Standby light is off. Standby light is on. All right. Just turn the mains off. Plug this back in. This is the transformer lead. I still have no clue what voltage should be coming out of that little power supply. I could probably work it out with the choice of resistors I've used on the switch mode power supply IC. If I look at the data sheet, I could probably find out what combination they've used to see what voltage they get out. Okay, everything seems secure. Main voltage on. Rear switch on. Okay, let's see if we have a standby light. And we do. Standby light is most definitely on. Let's measure that voltage while it's all hooked up. Definitely 1.8 volts, and it's steady. Completely steady 1.8 volts. What is the quality of that signal though? Alright, for shits and giggles, we'll plug this into my isolation transformer and pop the oscilloscope across the outputs there, and we'll get a better idea on the quality of that output and see whether or not it's doing what it should be doing. Okay, let's get the oscilloscope warmed up. Some probe leads with IC clips, so we can clip on those on that connector. Channel 1. Okay, now we have a wide angle shot. Let me just plug everything in and we'll go from there. Okay, test leads are on the output of our power supply. I've turned it on. Yeah, the oscilloscope seems to be tracking noise on the line, and it's sitting at about 64 millivolts over 1.8, which is fairly high for my liking, but it's not unreasonable. This is about 3%. One thing we could do is measure the other unit in its current working state and see if we have the same sort of signal. I think what we should do now is put it back into the unit and test the on voltage through the SigGen. Got you back over here with the subwoofer with the amplifier board back in. Only got 4 screws holding it in for the time being. So we can test whether or not we've been successful repairing the standby circuit power supply. Okay, we have our test rig set up. Subwoofer's powered on. our SIGGEN is hooked into the LFE port as per normal. Now you might remember that when we tested this unit over here, we had full on state reached at 0.1 volt on the LFE input. Hopefully, if all's working well with this, we should mimic the same sort of thing. 0.1 volt on the LFE here, and we should be good to go. Turning on now, basically straight on. Turning off, let it all fade out. Give it a few seconds, turn it off, on again. It's on standby. We'll give it 0.1 volt on an LFE input. Turns on. Give it some volume. Sounds like exactly what we want. So I think we have a winner. We've actually repaired the XLS-15s active subwoofer. No signal. Signal. Happy days. Thanks for watching. Like, share, subscribe, comment. Thanks.